Hello everyone and welcome. In this video I'm going to teach you the quicksort algorithm. This is a divide and conquer type of algorithm, meaning we're going to split our main problem into smaller subproblems, solve those subproblems, and then merge the solutions back together in order to solve the original problem. And we're going to do this recursively. This is a very efficient algorithm. In some programming languages that have a built-in sorting algorithm, it is usually a variation of the quicksort, and it's really not that hard to understand. So let me tell you all about it and how it works. So I'm going to sort this array right here using the quicksort algorithm. The first step is to choose a pivot. Now I'm going to choose 8 here as my pivot, and I'm going to leave it at the far right of my array. Then I'm going to take the rest of the array and I'm going to put the elements that are smaller than our pivot on the left of the array and the elements that are greater than our pivot on the right of the array. Now, how am I going to do that? Well, I'm going to have two iterators, I and j. I is going to start out at the far left of my array and j is going to start out at the far right of my array. I is going to look for elements that are greater than our pivot and j is going to look for elements that are smaller than our pivot. So I is going to go to the right, is going to go to 12. 12 is greater than 8, so we're going to leave it there. We're going to do the same thing for j. J is going to go to 6. 6 is smaller than 8, so we're going to leave it there. And now that we have I and j in their correct positions, we're going to swap the elements in those positions. So 6 is going to go to the place where 12 was before, right here, and 12 is going to go to the place where 6 was before. Now I is going to move here, 7 is smaller than 8, so we continue moving, and then 9 is greater than 8, so I is going to stay here. J was originally here, and so it moves to the left. 14 is bigger than 8, so we keep going. 9 is bigger than 8, so we keep going, and then we stop at 7. Now, at this point, the paths of my iterators have crossed, right? So instead of swapping the elements in those positions, I'm actually going to take the element in the position I, and I'm going to swap it with the pivot. I'm going to put 8 here, and I'm going to put 9 over here. And now I have split my array into elements smaller than 8, or equal to 8, and elements greater than 8, right? This is called doing a partition. It's basically breaking the array into two pieces in which one is elements smaller than the pivot and the other is elements greater than the pivot. Then I'm going to take both of these partitions and apply the exact same algorithm. Now notice that this partition is already sorted, right? So I'm actually not going to go over the process of sorting this because, well, it doesn't really make sense. I'm going to go to this partition right here and apply the same algorithm. I'm going to choose, for example, 12 as my pivot. So let me just copy this over here, 13, 9, and then I'm going to put 12 at the far right of my partition. And now I'm going to sort this partition. I is going to go here. 14 is greater than 12, 9 is smaller than 12, so we're going to swap those two. I'm going to put 9 over here and then 14 over here. Then both I and j are going to go to 13. 13 is greater than 12, so our iterator j is going to go here. And since our iterators have crossed paths, I'm going to take the iterator I, and I'm going to put the pivot right there, and I'm going to put 13 right there. So now we have two sorted partitions, and basically all we need to do now is merge our partitions together, right? So we're going to have this partition up here, which is going to be 3, 6, 7, 8. Then this partition right here, which is 9, 12. And then this partition right here, which is not yet sorted. However, we would sort it eventually during the algorithm, and we end up with 13 and 14. And this is going to be our sorted array. This is going to be the quicksort algorithm. So now let's talk about the algorithm's time and space complexity. So time complexity first. On average, this is going to have a complexity of O of n log of n. Well, why is this going to happen? Well, that's because if everything goes according to plan, we're going to successfully split our array into halves, right? Into partitions which are going to be halves. And so that's where the log of n comes from. And then to actually sort those partitions, we're going to have to go over the elements one by one. So that's going to have a complexity of n, right? So for that reason, on average, this is going to be O of n log of n. However, in the worst case, this is actually going to be an O of n squared. Now, I would encourage you to try to figure out why that happens, but basically assume that in every iteration of the algorithm, our pivot is going to be the biggest element in the array. Well, that means that we're going to end up with one partition that has the pivot, the only biggest element, and another partition which is going to have the rest of the elements of the array, right? And if this happens in every iteration of the algorithm, we're going to have to handle the elements one by one when we're splitting the array into partitions. So this is going to give us a complexity of n squared. Now let's talk about space complexity. So even though we're not using any extra space for the array itself, we are doing a recursive function, right? So we're actually adding frames to the call stack, which takes up memory, right? So in the worst case, the space complexity of our algorithm is going to be O of n, right? Because of the same reason why the time complexity in the worst case is n squared, right? Because if the pivot is always the biggest or the smallest element of the array, we're going to have to split the array n times instead of only splitting it log of n times, right? And on average, this is going to be then log of n, right? Because if everything goes to plan, we are splitting the array into halves in every iteration, which is going to give us a complexity of log of n. Now let's actually implement the quicksort algorithm in C++. Alright, so I'm here at VS Code. Now let's actually implement the quicksort algorithm. This is going to consist of two functions, one which is going to be sort of the main quicksort function. This is going to be the recursive part of our algorithm where we're only going to call this algorithm again with the partitions that we create. And the partition function is sort of going to be a helper function where we're going to do all of the process of incrementing and decrementing the iterators and swapping the elements that we need to swap. So I'm actually going to code the quicksort function first. As I said, this is going to be a recursive function. So the first thing we're going to do is our base case. And our base case is going to be, well, let me just say that this function is going to take in the array that we want to sort and the indexes between which we want to sort it. So left and right. So I'm going to say if right is smaller than or equal to left, then we're just going to return, right? Because if right is smaller than or equal to the left, then that means that we can't really break our array into any more pieces, into any more partitions. And so we're just going to terminate the algorithm, right? Then I'm going to create here an integer, which is going to be our pivot. And this is actually going to be returned by our partition function. This is also going to take in our array, our left, and our right, like so. And now, since this is a recursive function, I need to call the quicksort function with the left side of our array, so from left to pivot -1, and to the right side of our array, so A, and this is going to be pivot +1 and right. So this is the quicksort function. Notice that we're not using any extra memory, we're only basically applying the algorithm in different parts of our array. So to the left side of our array and to the right side of our array. We don't necessarily need any more memory. Now let's actually code here the partition function. This is also going to take in the array we want to sort and the indexes between which we want to sort it. So first of all, let me create our iterators. I is going to be left -1 and I'm running out of battery. Sorry about that. Then J is going to be right. And now we need our pivot. So our pivot is going to be the last element of our array. So the array at the index right. Then we need a temporary variable with which we're actually going to perform these swaps. And those are all of the variables that we need. Now our actual algorithm is going to be a while loop. So while I is smaller than J, we're going to increment I, right? So how are we going to do that? I'm actually going to use a while loop. I'm going to say a at plus plus I is smaller than the pivot. And I'm just going to end this here, right? This while loop is just going to have this one line. Basically, while the index I of my array is smaller than my pivot, I'm going to increment it, okay? And then I'm going to do the same thing for j. So while our pivot is smaller than a at index minus minus j. And in here, we actually need to protect ourselves from the case where j is equal to left. So if j is equal to left, then that means that we can't really walk any further left, right? Because we're going to go out of bounds of our array. And so I'm just going to say break here. So now we have our iterators in the correct position. All we need to do is swap. So if I is smaller than j, basically if we haven't crossed paths, right, if our iterators haven't crossed each other, then we're going to swap. So temp equals ai equals aj, and aj equals temp, like so. And once we're done with this, we only need to put basically our pivot in the index I, right? So I'm going to say temp equals ai, and then ai equals a right, which is our pivot, and then a right is equal to temp, like so. And we're actually done with our algorithm. Now, as I said, the partition function is going to return the new position of our pivot, so all we need to do is return I. Then we're going to go back down to our quicksort function, and we're going to apply this algorithm to the left side of our array, or to the left side of our pivot, and to the right side of our pivot. And that is basically all that we need for our quicksort function. Now in my main function, I actually have here the array that I want to sort, its size, and I have here a for loop that's going to print the elements of that array. Now down here, I've already printed our array. It is obviously not sorted yet. So let's apply the quicksort algorithm here. So this is going to take in the array that we want to sort, then our left, which is going to be 0, and then our right, which is going to be size minus 1. Now, if I run this again, notice that our array is now going to be, sorted, as you can see. So that is how the quicksort algorithm works. I hope this video was helpful and easy to understand. Thank you so much for watching, and I'll see you in the next one.